the Shinachitra Shinachitra This topic is best hemorrhage detection in brain CT scan slices using projection profile-based decision trees.
Alright, so good afternoon, Professor, and good afternoon, Nikki. Today is such a great honor for me to be here. And actually, I'm Cambodian, and I study in Thailand. And I study in Thammasat University, which is and the name of the institution is SI. Right, so without further delay, I would like to introduce my topics over here. So my topic is about the fast brain hemorrhage detection using projection profile-based decision tree. And our crucial work is going to be the automatic brain hemorrhage volume approximation. Okay, so this is my contents. I will go briefly with all of this. And okay, and so let's come to the introduction. As you know that currently most people are having problems with brain hemorrhage, especially from the stroke or many accidents, like especially the head accident. And this head accident is known as the head tumor and also the head injury. And as you can see, when people have the brain accident, when their head crashes to something, the blood bleed into the brain, and this is called hemorrhage, which is what I'm going to do now. And so what caused the brain hemorrhage? There are many factors, like the internal factors and the external factors. So the internal factors consist of these 3 points, like the blood vessel is already weak, and so that the leakage of the blood lead to the brain, and then it can be because of the high blood pressure as well as the bleeding disorder as well. And the external factors like the accident, fallings, and many things more, violent, domestic violence, something like that. And so this is what I'm going to do. Like this is the CT scan that I get from the CT scan machine, and this is the real one, if you can see. This is the picture of the brain hemorrhage. Okay, and this is some introduction about the machine. So there are 2 ways that we can get the picture that we scan through the head. One is the CT scan, and another one is the conventional one, which is the MRI scanner. So now we are going to work on the CT scanner. Okay, so what is the problem nowadays? The thing is that nowadays we have the doctor to cure this kind of problems, but we are now developing an automatic machine, an automatic software or application that the doctor can input all of the slides of the hemorrhage and can detect it faster and quicker. So this study will have to provide more understanding to people from diverse fields and encourage researchers to improve the research on the medical field, and as well as to have the neurosurgeon identify the hemorrhage. Okay, so now let's start identifying the part of the brain. This is the color, the RGB picture, but to be honest, in the CT scan, it's not going to look like this. So as you can see, this is the hemorrhage, this is the ventricle, and this is the skull. And these 3 main parts are the things that we are going to work on it. Alright, so and another thing is that we have different type of hemorrhage as well. The bleeding can be here, and as well here. And this is different type of the CT scan that is gonna look like this, and we are going to work on these features. Okay, so now, okay, now I'm trying to categorize all of the parts of the brain. So this is the hemorrhage, as you can see. This is the ventricle, which is look like a butterfly, and the gray matter over here. And the skull is the last one. Alright. And there is some like noise, little noise here, which is like the structure about the detail of the patient. So we will do some removing those which the area that we don't need. Okay, so our main method, our proposed method is the projection profile. And we do the projection profile from both horizontal line and vertical line. And as you can see, after we do the the projection profile, we can get the graph over here, which is this picture consists of three graphs, which is the sum of intensity, the sum of the standard deviation of intensity, and last one the mean of intensity, which you can see over here. And we're gonna get the max over here, which occur on the hemorrhage. All right. And by doing the projection profile, we will get it into one we will collect the data into one dimensional profile, and we will do the next step, which is the feature selection. All right, and after that, we are going to remove the skull and some little noise over here. So by removing the skull, we use the method called erosion method. So we use the erosion method. The thing is that we can do this removing skull in two ways. One is the threshold method, and another one is the erosion method. For the threshold method, we can set like the range. For example, if it is over than 250, which is white, so just remove it. But it cannot be removed totally because, as you can see, there will have some little noise around it if you use the threshold. That's why we decide to use the erosion method, which can remove like this. And this is the picture that has no hemorrhage, and this is the picture that has hemorrhage. And after removing the white area that we don't need, we then choose the basic features. In total, we choose 8 features to put in the decision tree to classify whether the site is having hemorrhage or not having hemorrhage. Okay, and then for the threshold method, because we're going to compare our work, our projection profile with the threshold work. So we try to implement the work in order to compare with our work. So then from the experiment, we can set the background, or we can get the intensity range of the background is 0, and the scale from 240 to 255. And the gray matter is around this number, 95 to 155, and the vertical 5 to 80. And this one is very important, the hemorrhage, 157 to 211. This is like the gray matter, the combination of white and gray in this one. And our experiment, we have chosen the total CT scan from 121 patients, which consists of 1,451 slides. As you already know that in each CT scan slide, it consists around like 70 or 80. But for the part of the brain, it consists only 20 slides. So then we collect all of the slides that have only the brain part. So we sum it up, and it's 1,451. And then we chose the slide with hemorrhage, 371 slides with hemorrhage, and 378 slides without hemorrhage for training.